See how it goes. So we're up to the third part of analyzing Android applications, and then I'll demonstrate a couple more projects. So we're down to more about the security model and reverse engineering applications, which we're going to have several projects about. So this is basically Linux security. And in fact, it's a whole lot easier to understand this security stuff if you take the exploit development class, which will come in a future, maybe next semester it'll come around again if you want to take that. That's where I really learn this stuff from the attacker's point of view. Now, generic exploit mitigations are hardening the operating system so it will affect all applications, even applications that are old and have not been recompiled. It protects them sort of by putting a container outside them. This makes the underlying OS more secure. And these are all just inheriting from Linux. Android is very close to Linux. So, stack cookies, for example. The original vulnerability that was responsible for most of the malware on Windows up through Windows XP was stack buffer overflows, where you have a string and you're able to write more characters than you should to a string, so you overwrite memory until you hit the return pointer at the end of a stack frame, which can be used to hijack execution. And the cure for that was to add a stack cookie, which is a random number at the end of every stack frame, and if that number has changed, you stop the program. You cannot continue. So nobody is able to overwrite data and get to the return pointer without overwriting a stack cookie. So that's an exploit mitigation. Safe IOP helps prevent integer overflows, which I haven't heard that much in Android, but it's a big deal in Solidity, integer overflows. And if you use, it's again usually a fault of C. If you define an integer variable, it goes to a maximum like 255, and when you add more, it rolls around. So you can often get away with, they try to say the length of a string has to be less than 10. I could make it 265, and that would appear to be 10. So you can sneak extra data in, and then you can have an overflow with the other type we're talking about. DL malloc is really important for stack heap vulnerabilities. Unfortunately, in C, you have to allocate space on the heap, and when you're done with it, you have to free it. This turned out to be a really miserable idea. If you forget to free it, it becomes a dangling pointer you can write to memory you shouldn't be able to write to. If you accidentally free it twice, it has bad effects too. And by the way, Rust fixes this in an incredibly simple way. You allocate it, you use it, and as soon as it falls out of scope, it automatically frees. That's it. You don't have to do anything. You don't have to remember anything. Most of the C flaws come from expecting the developer to remember something complicated and difficult, and like remember how long every string is, and don't put more than that in there, instead of doing that automatically for you, which is what Rust is, which is why, Mark Rusinovich is saying we just need to start writing stuff in Rust and abandon C and the whole family, because Rust is almost as fast as C and much safer. They sort of took the top 10 problems of C and fixed them. Anyway, here's another way to prevent integer overflows and format strings. I was just teaching this over the weekend. C has a bizarre property. When you print something, you're supposed to have a format string that specifies how it prints, but you are allowed to print something without specifying the format string. And if you do, that becomes a exploit hole that can be used to completely take over the machine because of some bizarre formats available in C, the most bizarre being %n. The %n format will write to memory, with the memory address coming from the variable. So it's completely insane. It's like they put it in there just to help you hack the machine. It's hard to think of any actual legitimate use for the thing. But anyway, that's why print statements can lead to them taking over your machine. And they put in a protection against that. Non-executable is extremely useful. This exploits a property of all motherboards. They've all had this for at least 10 or 15 years to put permissions on RAM. So when you allocate a memory region for use by a program, you can say this is writable but not executable. And the one that's executable is not writable. That way, the attacker is not allowed to modify a region and then execute it. They can modify strings, but they can't execute them. This is part of the fundamental Windows security model. Every region has to be write or execute, but not both. And that's what's going on here, the no execute bit. ASLR is randomly choosing a location in memory where a process launches every time it relaunches. So you don't know where you are. This stops a whole bunch of attacks that depend on feeding a number into the instruction pointer and jumping to code you've inserted because you can't find your code. It randomly moves. And that's this layout randomization. And in order for this to work, you do have to recompile applications with position-independent executable support. Your applications have to be compiled with a little bit more complexity so they can be randomly located in memory. They have to use only relative jumps, and any fixed addresses, they add a special section to the compiled code that fixes all those fixed addresses every time it loads in memory. So there's one thing about this ASLR is it does not work for really old code that hasn't been recompiled. If they don't have this pi feature, whoa, I somehow hit the wrong button. If they don't have this pi property, then they cannot use the ASLR. And relocation read-only is another way to prevent people from overwriting the relocation records. We were also doing that yesterday. If you want to take over a machine, if in a heap overflows, typically do not give you the ability to inject code where you can run it. What you get is you get control over one write operation. So how do you take over the machine with a write operation? You write into the global offset table. The libraries, you do not jump directly to a library like print. You jump to an offset table, which then points to the library. So you rewrite an offset table record, and now when the program tries to execute a system call, it goes to code you chose. And that's what this prevents it. This prevents people from altering the relocation records, which is a common way to take over machines. And Fortify Source is a general fix to try to improve C in general. Microsoft did something like this. Microsoft released about 5 years ago their custom C libraries. They took like the 20 C functions responsible for most of the problems, and they replaced them with custom functions that are more secure. The one way to try to fix C. This is essentially the path that eventually led to Rust. People got so tired of this crap happening in C, they started having patches to try to make C more secure, and it still didn't work. But this is one way to replace all the most dangerous functions with safer versions. Right, and SE Linux is developed for the military so they can pass military requirements to handle classified data on Linux machines, and it adds a whole lot of extra security features to Linux, where each application is only allowed to reach certain folders, only allowed to do certain things. It's sort of like a granular firewall at the application layer, and it's included in modern versions of Linux like Ubuntu.
So
if you
it's like Mac that prevents software from accessing this folder and this folder?
Yes, it does. It limits what folders they can write to and what they can do. It's sort of like the permissions for an Android app. This one can hit the network, this one can hit the folders. It adds a layer of security like that to Linux and Unix machines. And one thing about it is that you can have it in an enforcement mode where it actually blocks activities, or you can have it in a logging mode where it lets you do anything but it records it so you can check later. And of course, if you're going to run old applications, it will get in the way. And you'll have to lower the security for them. So that's SE Linux in enforcing mode. All right. And then there's kernel protections. SetUID and SetGUID are the classic ways to elevate privileges. For example, if you are a non-root user on a Linux machine and you want to change your password, you have to write to the password table. But the user does not have that privilege. So what they do is they define a function, PASSWD, and they make it a SetUID, make it owned by root, but it has SetUID and all execute permissions, so anybody can execute it, but when they execute, it runs as root, even if you aren't root. This is the classic way you elevate temporarily to do something. In Windows, this box will pop up saying, you need to be administrator, do you approve that? The problem with this is how you attain privilege escalation as a hacker. All you have to do is find one of these things that escalate temporarily and crash it while it's high. And then you're up. That's essentially how most privilege escalations work. So they've removed these things and found ways to work around them without using SetUID.
So you set the copy the SetUID function into the password?
Yeah.
So that's,
What's that?
so that's how you escalate the privilege?
Yes, that's how Linux works. The password function is a SetUID function. And there used to be a lot of them all over the place, and each upgrade in Linux, they cut down the number of SetUID functions. And here they're removing, they're restricting it in Linux, in Android too. I don't know if they've gotten down to 0 in Android, but they try to have less and less of them because they're all very dangerous.
But
Yeah.
if that SetUID function is only in specific things, how do hackers override it?
You have to find a flaw in that thing.
Oh, okay.
And the most common thing is you find a race condition where you call it many times and get it confused. You have some condition that causes it to stop, or some condition where you can add an extra command while it's still running. That's the most common one. That's what the dirty cow exploit was. All right, and so then rooting, of course, if you want to run your Android as root, By default, you don't have that privilege, although they don't try vigorously to prevent you from doing it the way Apple does. Apple gets real mad and blocks the jailbreaks and patches them. They don't want anybody running as root. But Android is supposed to be open source. They say, well, you're allowed to run as root if you want to, just like Chromebooks. Chromebooks came with a switch. You can switch it to root if you want to. You're going off our map and we're not going to support it anymore, but you can do it. And so there's a lot of ways to do it. So the simplest way, ultimately you want to add an SU binary, a super user binary. Now you can execute SU to elevate to root. So SU itself must run as root. So there's ways to do it. Like say SUID is a way to do it. This is what it looks like. The SU has read write, re-execute, read write execute, and read write S. The permissions have this is the special permission, which means that anybody can execute it. The owner, which is root, or anybody in the same group, or anybody outside the group. But when they run, it will always run as root. So you can run SU without being root, and you can it'll elevate you to root. Now, that would be a security flaw if bad guys could use it. So on Linux, what they do is they pop up a box, just like Windows, saying, is it okay with you, the Android user, that this app escalates to root? That's a pretty good answer. Then you have to have permission from the user. Now, if somebody stole your phone, they can root it, but there's no way to stop that. But at least this way, an app can't escalate to root without you knowing that's happening. So, all right. So you can use an exploit. There's one way to do it. You can use an unlocked bootloader, so you reboot the machine in a different operating system mode. So there have been a whole lot of exploits that will jailbreak phones. Gingerbreak was one of the old ones in early versions of Android. This would write to the global offset table, the one I was just talking about earlier, the pointers to system routines, and then you can run. So that was a bug in Google's original Android code. Then there was Exynos in Samsung's driver, so it would work, but only for those devices. Then Samsung and
Couldn't you get the phone and then reset it to become you have control of everything, right?
You could, yes, but what you usually want is you want the user's data, and that's not easy to get on the iPhone. But yeah, if you could root it with one of these exploits, then you can get the user's data. That's what if you just reset the whole thing, then you can use the hardware, but you've lost the data. And typically, hackers want to steal your personal data. That's why they're hacking your phone. And they want to do it with like a malicious app. From a distance, they don't even want to steal your phone. They want to have an app where you install the app and it steals your passwords and sends it to them, and you don't know that happened. And that's what would be possible with these. So Samsung and Meyer would exploit dump files and logs to change permissions. Again, only work on certain devices. Acyconia is another one. This is quite the case with Windows machines too. I mean, the underlying operating system has gotten pretty good, but the applications written by third-party developers are more likely to have flaws, and so often your hacks only work on machines that have certain software. And the manufacturers put their custom software on there, and that stuff tends to be really crashy. And then there was the master key vulnerability we talked about last time. You can take a signed app and you can add a second file with the same name as a current file, and it will not notice. The signature will still be passed, so that you're able to take over the box with this by modifying a system app. So your application runs with system permissions. And then there was towel root, which exploited locks used when threading. This is essentially a race condition, like I was saying. There things get locked, and so this got into a lot of devices. These are all old exploits, but they work on older versions of Android, which are unfortunately still in use. People use a lot of old Androids. And so the other way, of course, which you were talking about, is just to max new firmware, have a different version of the operating system under your control. Then you just totally get to use the hardware with no restriction, but of course you don't get the old data. So a new recovery image or a rooted kernel image, and of course this will void your warranty. As far as the manufacturer will not want to help you if you foul up your phone. It's the same thing as jailbreaking your iPhone. After that, Apple doesn't want to hear about you anymore. So there used to be a whole bunch of these custom ROMs, like Clockwork Mod was a big one, and another one was Cyanogen Mod. They were all over the place, but they all pretty much vanished about 5 years ago, because what happened is the main reason people did this was to get features that were not possible for with built Android, and the basic Android got better, so there was less desire for this. Can I provide a mic so remote students can better hear questions? No, I don't have an easy way to do that, but I can repeat them if questions come up. Just remind me. Okay. I forget what he said, but it could just remind me to repeat the questions. That's reasonable. All right. So Paranoid Android was another one. and there was a popular one, and again, they just abandoned it. They weren't making enough money. Nobody really cared. You know, after Android got better, nobody really wanted to like put these custom ROMs on their machine very much anymore. So then reverse engineering applications, and we'll talk about this. You can pull an APK from your phone with ADB, and if I can zoom in, I think I can zoom in. There we go. So let me make my window wider. There we are. All right, so you do ADB shell, PM list packages. This is package manager. You can list all the packages on your phone, and you can grep for a string. So here's the Progressive. This is the Progressive Insurance app. We'll use it in the project. So now you see there is a app named Progressive, com.phonevalley.progressive. So now you find the path to it with this. Here's the path on your phone, data app, com, all this jazz, ending in APK. Then you do ADB pull, and you get the APK on your Linux machine. Now you can analyze it. You can do it on Windows machine too. Now you use an unpacker like APK tool, and it unpacks all the resources, and now you have the code for that Android app, so you can analyze it. All right, that's the basic activity. Now, we're going to do it by hand for a few apps, but another thing that's a lot more fun is to use automated scanners. Quark is one, and Androbugs is another. You just feed it the APK file, it unpacks it, finds all the vulnerabilities it can find, and just reports them to you. This is true in all security work. They have these security scanners, and they're not perfect, but they're pretty good. The main problem with them is they all bother you with like a whole bunch of boring reports of things that don't matter. They report every possible thing that looks funny about the app, so you have to get good at removing the false positives. But this one here, for example, I think I can zoom in again. This one here was Quark, I think, and it found that the app was using login. And it found that it was using SSL incorrectly, which is totally true, and it found an API key. So those are all pretty good. A hard-coded key in the code, logging things. The recommendation is your production app should not log anything at all, because you might log something sensitive like a password, and why would you? And of course, this is the vulnerability we'll have a lot in the projects, things that break SSL. They allow you to intercept SSL traffic, and they don't notice because they don't actually verify the SSL certificate. A lot of apps have that problem, something like 5% of them. And here's another one finding the same problem. This app does not check the validation of the certificate. Critical vulnerability. And you can actually get fined by the Federal Trade Commission for that one. It has happened to a few companies. All right, and JADX is a graphical tool that will let you explore an app and view the source code in what looks like Java here. So you just go through all the pieces of the app, and you can see the various pieces. And we'll do one here. There was an entertaining hacker who hacked into the Indian identity app that had a bunch of protections. I think he's in French, but he hacked into the Indian identity app for some reason and showed us how to do it, and so I put it in the projects. Anyway, and then there's code modification. This is what you do. This is what the code looks like in Smalley code. And what I've learned is just a couple of these Trojans. You can add a Trojan. This will just log something. So I can put something in the log and then steal things. So I figured out that there was V2 and V3 are the variables. V2 and V3 are registers. You have up to 16 of them in each method. And up here, you can tell what they are. Here it's putting something in V2. And what it's putting in V2 is this object, which is the username. You see, they give it a nice name, username text subject. So that's the username in V2, and this is the password in V3. That's what I mean. It's not hard to find in here. You just look for the word password. You'll find them putting the password somewhere. Then you can just add code that steals the password, and then recompile the app, reassign it, and now you have a malicious app that will steal the passwords when people use it, but it'll look like the real app and work like the real app, unless they have defenses. And nobody seems to bother with defenses except the NFL that got humiliated and upgraded their app to where it actually has an integrity check. But all the banks and insurance companies and stockbrokers don't bother to verify the integrity of their app, which I used to irritate them about. I've sort of gotten used to it now, but it is ridiculous. So then you repack your app here, use APK tool B to rebuild your app, and then you sign it with jar signer. So now it has a signature and it can be installed on a phone and used, but it will not be accepted as an upgrade to the official app because it's not the same signature. So you have social engineering. You have to trick people into, oh, you have to uninstall the old app and put on this one. This one's much better, or get somebody to install it who doesn't already have the old one installed. You can put it in stores, especially in other countries, and for people with cheap phones, a lot of them don't have access to Google Play. Like in China, they block Google Play at the Great Firewall, so everybody has to load from other stores. And a lot of cheap devices don't have access to Google Play because they don't meet Google security standards. So again, they have to load their apps from third-party stores, so you can get your malicious apps in those stores. So anyway, it's one way to hack people. So let's take a look at a Kahoot, which I might have ready to go. I do have ready to go. All right. 128.6c. By the way, the question issue is actually bigger going the other way. There's only 3 physical students in the room and like 19 online, so it is, it's actually more likely that they need to hear the questions you people are asking in chat than the other way around. Although nobody's asking questions in chat today. But anyway, I just found out the college is implementing a program to do this revolutionary new thing where you let students be in the classroom and online at the same time. So I said, well, I could volunteer for that. But they say they're going to fix microphones in the room to fix this issue. So supposedly, in about a year, I'll be in their pilot program of that. And then we'll have it to you in a room with microphones and stuff. However, it'll be run by the college, so I expect it won't work. So I don't use any stuff from the college anymore. I've been in a few pilots like this, and you learn not to use the college's stuff. What's that?
How long have you been doing that?
This way, about 4 or 5 years, which was handy when the pandemic hit. I already had the system worked out. Because I just realized, why would students drive in to just listen to a lecture? It doesn't make any sense. After, I found tools like Zoom that got good, so you could actually do it. Oh, an actual hacker, uh-oh, we're in trouble now. I don't know, you can get an actual hacker certificate. The kind of thing doesn't really come with clear credentials. All right. Okay, good thing. I'll wait another few more seconds. Oh, you got it. Good. Okay. Good. Okay. All right, so where did the canary value go? All right, on the stack, that's where it goes, at the end of a stack frame, where a return value is placed, which makes it very easy to hijack the execution. All right, what's the target of a double free exploit? It's the heap. You use alloc or malloc to reserve space on the heap and free to free it, but if you free the same thing twice, you end up creating a pointer that can be used to write to area you shouldn't be writing to. All right, what exploit uses 2 files with the same name in an APK? That's master key. You know, I'd like to figure out how to do that. I don't know how to make a zip file with 2 files with the same name. You'd have to maliciously modify it. I guess it's possible, but it's not immediately obvious how you would do it. So what is the target of a format string attack? Print statements, good. Rouhani's doing well. And what does the NX bit do? Yeah, the stack. NX applies to memory regions like the stack, and the stack in particular is not executable because you write data to that. And it's writable but not executable. That's what you use the NX bit for. All right, Luca, looks like a real name. That's a real name. Close to it. There we go. Good. All right. So let me stop this recording.